Welcome back to another video. In this video, I will talk about the document input and output database of a control system. In short, I/O database. The I/O database includes details of all input signals and all output signals of a control system, which can either be from a field instrument or even from another control system. Very often, this document creates a bit confusion for an instrument engineer because all the details mentioned here is from the control system point of view. The first step in making this document is to collect all the signal informations from the vendors of each field instruments and from the vendors of other control systems connected to the reference control system. These informations roughly include the tag number, signal description, signal range and its unit. Once all the input and output signal details are available, it is then categorized into digital input, digital output, analog input, analog output, RTD, thermocouple, Modbus signals, OPC signals, and so on. Next, these I/O signals have to be allocated and distributed to its respective I/O modules. The control system design engineer makes sure each I/O modules have a minimum percentage of spare channels for future expansion or channel failures. The designer also makes sure the I/O signals are not overloaded into the controller, or in case of multiple controllers, as like in DCS, the I/O signals can be divided among the controllers too. Now let's have a look on to a sample of I/O database document. In general, we have two categories. The first one is hardware I/O database, and the second one is software I/O database, also known as communication signal database. Let's go for the hardware database first. As the name indicates, these are the signals physically connected by cables. It shows the signal tag number, description of the signal, type of the device like flow transmitter, temperature transmitter, level switch, control valve, motor operated valve, RTD, etc. Then it shows I/O type like analog input, analog output, digital input, digital output, RTD, thermocouple, etc. Then it shows the type of signal, if it's 4 to 20 milliampere or an RTD or 24 volt DC, etc. The contact type is only applicable for DI and DO signals. NO is normally open contact and NC is normally closed contact. The power source describes whether the signal use the internal power of the control system marked as I or the signal use external power marked as E. The column from or to shows us the path of the signal. This one is from field to control system. This one is from control system to field. This is from motor control center to control system, etc. This shows the process range and unit of the signal. For instance, here it means 0 to 200 turns per hour, and here 0 to 100%. The next set of columns shows the alarm set points of the signal: low low, low, high and high high respectively. The cable termination details are shown here: the marshalling cabinet name, terminal block number and terminal number. The next set of columns describe the signal allocation in the control system. It includes controller number if you have multiple controllers, rack number, slot number, the model number of the I/O card and the channel number. As like other documents, make sure we refer to the latest revision. So this is all about hardware I/O database. Later, I will make a separate video on NO signals, NC signals, internal power signals and external power signals. Next, we will have a look on software I/O database. This refers to signals using communication protocol like Modbus, Profibus, OPC, etc. This is a very vast topic, and here I will include only an overview. Usually this communication method is preferred when we have a large number of signals but wants to cut short the cabling cost for each individual signal. As these are communication signals, in my opinion, these are not so reliable too. The first few columns will look similar to that of hardware I/O database. Here we have tag number, description of the signal, device type, I/O type, contact type, process range, process unit, and alarm set point levels, etc. The next set of columns will describe the parameters of communication, and it will differ for each communication protocols. For instance, if it's a Modbus TCP/IP protocol, we need the type of the signal like float, integer, or boolean, etc. Next, we need the memory address and the bit number in case of a DI or a DO. In case of OPC protocol, the I/O database will include the data type and the OPC item name. The OPC item name is unique for each signals. So that was an overview about input and output database of a control system. If you liked the video, give it a thumbs up and consider subscribing to this channel if you are looking for contents of this kind. See you guys on next video.